Okay, thanks everyone for coming. So I thought we should just share with everyone what's happening at Orion Health these days. We are in the health tech space, and it's pretty unique in our kind of restrictions we have. So today will be myself and Anna. We're both software engineers at Orion Health, going through this transition. How do we modernize Orion going forward? And how do we actually add serverless capabilities to Orion with all our restrictions? So Orion Health, what is it? Orion Health is a health tech company, and we're actually building the runtime for healthcare. So what does that mean to us? We have multiple clients like HIEs who have to, or which health interchanges, which have to share information between hospitals. And then we have hospitals who actually need electronic medical records, and they need to derive information out of those records. Also, they need to derive value using machine learning for their precision-driven health initiatives. And we also get use cases where we actually just need clinicians. They need to be able to access a client's information and then make decisions based on that information and the historic value that that brings to them. Within Orion Health, we have a small team. Our team is focused purely on the next iteration of Orion. This next iteration of Orion needs to be future-focused and make sure that it can last for the next 10 years of Orion. So why a new platform? So in order to understand why we're building this new platform, you have to understand that we are in this age of accelerated AI, and how do we bring that to healthcare? This is what we have to focus on. This is challenges that we bring, and we need to still ensure that this platform that we build actually can be used as a runtime for the current stack of Orion. So how do we enable our legacy and build upon that to enable clients with the future? So we have some standard textbook requirements. So these textbook requirements are that everyone gets. You know, it needs to be customizable, it needs to be secure, especially in the health space where we're dealing with personal health information. We have HIPAA to comply with. We have PII. We have all these basic requirements on how do we secure data so that we don't have any data breaches that could jeopardize our patients of the actual clinicians of our customers. So we also have modular. We must be modular. Whenever we have a client, they need to take certain aspects of it and build up their own solution that meets their specific needs. So we can't just have our opinionated view of how health solutions should look, and we just tell them, you know, take this or nothing. So they actually build it based on our components. Agility is another big one for us. How do clients stay agile, stay relevant in the market? How do we stay relevant in the market by enabling our clients? So this is a very interesting one for us, and I'll come back to that later. But it's key to us. Also automated. So our systems, we must ensure that they're automated from day one. Everything from how do we generate code, how we capture business needs, how we deploy our actual runtime on top of our platform, and also post that. When we actually get problems in production, what do we do about it? We must ensure that we have capabilities then to handle that in an automated way. So Orion has been using serverless for this function quite a bit, and we'll get into it a bit later. The other requirements we have that are quite interesting to us is our deployment models. What do we need to support? We need to support cloud agnostic, so we need to support AWS, we need to support Google Cloud, we need to support Azure, we need to support private clouds too. But on top of that, we also got this requirement for on-prem. Now that's the very hard one for us to solve. How do we do serverless with on-prem? So on-prem is interesting because we have a finite set of resources, but we still want these great capabilities that serverless brings. So how do we do functions as a service? How do we deploy data storage? How do we enable machine learning as a service for our customers? So that comes to our serverless. So customers should be solving their needs. It's as simple as that. They should not be worrying about the underlying execution environment. This is regardless of whether they're running in the cloud, where they have a supposedly infinite amount of resources, or whether they're running on-prem, where they have a finite set of resources. It should be the same to them. So they should just provision X amount of resources and say, Orion, this is what you have to work with. Please go do something with that. That's of value to us. So we started this journey of this new platform, and we had to have really targeted building blocks for initial phases. So what we decided to do is we focused on domain models. How do our clients capture their business requirements and the data storage needs in a technology agnostic way? So we have a solution to that, which we'll get into now. Also functions as a service. So it's great that we can store domain models, but what happens if we don't get it right? What happens if we add this little bit of functionality to make sure that this particular solution fits the client's needs 100%? There's another interesting aspect with function as a service that we'll go into later. Machine learning as a service. So this, again, everyone has their models and has algorithms they want to deploy, but now how do they manage and run that? So we need to build that into our platform. It needs to be a holistic view, so not only from a business perspective, but from a running system perspective. So how do we use outlier detection to see if our servers are in a vulnerable state so that we have to actually intervene and do something about it? We have a lot coming soon too, so this is only a start. We will be evolving this over time. So let's take a look at our domain models. Our domain models are built by domain experts. So this is your clinicians or agencies working in conjunction with your clinicians. They use a domain-specific language built on our tooling, and this tooling gives them everything. It gives them a partially implemented domain packaged in a container that we can then shift over to our fabric, what we're calling our fabric. And that fabric contains our runtime, and it runs on our platform. Now, if you look at the Lego block, you'll notice that it's half-colored. So we have an opinionated view of how domain models should look. So we give you that, you fill in the rest. So we don't force it upon you, and we give you the ability to extend our domain models. Functions as a service. This is another aspect of serverless that will really help our clients. And this is built by software engineers or consulting experts. We support Java and Python, and in this case, what you do is you do your little piece of functionality, and you attach our runtime on it, so you'll get all the good benefits of ours, like our security, for instance. And then you take that, you package it, and you put it in your marketplace, and you deploy it to our framework, to our platform. And then we run it for you. So you can see all these cases, the common theme is we don't want our clients worrying about what the underlying infrastructure is and how it's executed. It must scale up and scale down to their needs. Machine learning services. So we have a library of, I think, 30-odd algorithms models that we have. Clients can also build their own. And again, we have a runtime. We have, the platform. On the platform, we have a runtime, and you just give us your model. We'll run it for you. And it'll fit into our ecosystem. It'll be accessible to all the components. We'll manage the security around it. And we'll manage the fabric, so we allocate enough resources to you as your needs, for your needs. So this is a great vision, but now how do we enable this? And how do we enable this in an environment where we have both on-premise, or doesn't really matter, it can be in the cloud. We need to put a platform on it that has domains, functions as a service, and machine learning as a service. For our platform, what we've chosen is Kubernetes. Kubernetes is very interesting. It's very critical to us. It's not the be-all and end-all, but it really enables us because of its scaler. So it's scheduler. That's what really allows us to scale the fabric back and forth in order to meet the needs. Because we have other requirements, such as when we onboard a customer, we need to use the fabric for a different purpose, which is onboarding a lot of data. And then when we go into business as usual, we need a transactional system. That transactional system then has to take over and use more of the fabric when it's business as usual. And obviously when you're onboarding, you need data loading as your actual business as usual. So you allocate more on onloading to the data loading, and business as usual, then you scale your fabric back and you give all of the resources to your transactional system. Kubernetes is another key enabler for us. Kubeless. So Kubeless is a function as a service that gives us function as a service native-like functionality on Kubernetes. This is what allows our clients to go and write their little piece of functionality and deploy it to our fabric. And this is to fill that gap of needs, as I mentioned. So the other two were a bit tricky. So we scoured the market and we couldn't find anything. So what we did is, this is where Orion has built RP and bespoke software. So using our tooling, you can now go define it. Very important thing is, with these domains, with our custom tooling, you actually define your data source, how you must index it, whether your data is temporal, time series, how we must index that data, and what a summary looks like. And based on all those characteristics, you can then just deploy it and we run it for you. So you can see the key theme of this is customers don't worry about this bottom section. We do. And what that enables us as well in the future is if customers decide they want to move from an on-premise to a cloud, it's an easier migration for us. It's not dead easy, but it's an easier migration. It's an enabler. It takes a lot of the friction out of doing it because we have a whole bunch of services now for public cloud, like EKS on Amazon, and Google has a Kubernetes offering, and DigitalOcean is in a preview. So all the cloud providers are going towards Kubernetes. It's just how we use that in the future. And we are placing a bet on that in the future that will be serverless too. Kubernetes offerings will be serverless. So you'll get this infinite amount of compute power that you can deploy to. So if you look at everything I've shown you, key benefits are in agility. So both for us and our clients. So how do we meet the market sooner using functions as a service and our specific domains with not bogging down the clients on resource requirements? And how does the client actually meet their market needs using functions as a service? Portability, that's where Kubernetes comes in. Now we can deploy on cloud, on-prem, or we can migrate from on-prem to cloud or cloud to cloud provider. And that's the key benefits we are seeing in it. The other thing that Kubernetes offers us is this increased infrastructure utilization. Currently, when we deploy our monolith, we really don't use the servers. We have very, very, very low resource utilization. So what Kubernetes offers us with the scheduler is the ability to then have really, really good server utilization. And we can carry that over into the cloud or on-prem. The other part we really, really want to see is this overall cost of ownership decrease for our solutions. So the fact that we can do more with the current resources we have means it should be an overall cost reduction. These are metrics we want to measure ourselves upon and we want to get right in the market. So just keep in mind that you'll be seeing a demo now from Anna. And just notice the simplicity we want to keep because we don't want to build anything. We just want to make sure we use things out of the box. And we only add our runtimes on as we need. So this is very key to us because we believe that all the cloud providers will soon offer everything we do now. So it will be a matter of how can we best deliver to our customers rather than worrying about the technology stack. Thanks.
Hi guys, my name's Anna Spyker and I'm a software engineer at Orion Health. I'm going to show you a demo of the products that we have that enable serverless capabilities for a patient and a GP and a journey of the patient through their system. Due to time constraints for this demo, I'm just going to go very high level over the concepts. But if you guys have any questions, you're welcome to come and chat with either of us afterwards and we'll explain a little bit more in detail. So first, let's meet the actors. So we have Jane. Jane is a patient. So Jane is due for her replacement hip surgery. So she's going to go up to her GP to discuss her upcoming options. Now meet Melissa. Melissa's a GP who uses Orion Health Systems. So when Melissa has her consultation with Jane, Melissa wants to provide Jane some insight into whether she should go ahead with her hip replacement surgery, weighing the costs and the benefits to do so she can make an informed decision about her surgery. So I'm going to show you what we're going to create here. So Jane is going to register at home what her patient information is, so Melissa can have that when she arrives at the GP. Melissa, the GP, wants to provide Jane with a risk score for her operation. So the grayed out areas you can see here are the areas that we need to create and able to enable this for Jane. So we need to be able to create a function using our functions as a service. We need to be able to define the patient details domain for Jane's data to be stored in. And then we want to deploy a machine learned model that will calculate Jane's risk score and then give her information about whether she should go ahead with the surgery. So to do that, we need to first store Jane's patient data. We need to provide the ability to capture those patient details in the storage. And then we need to utilize this data to make a prediction for Jane. So first up, we've got a demo of our domains and functions as a service. So we get to that. Cool. So this is a patient details form. This is a typical form that you would fill before you went into a GP. In this case, Jane can fill this out at her own home before the appointment. But currently, all we've got is this form. We don't have anywhere to store any of this data. So what we're going to do first is define our data storage. So to do that, we use our domain tooling. So this is a typical drag and drop tooling where a subject matter expert will be able to define the patient detail domain and for Jane's personal information, so she can define exactly what information she needs from the patient before the appointment. So you can see here we've got full name, date of birth, things like that. So when the subject matter expert is happy with this domain, they can press deploy, and now that domain is now deployed into our system. You can see this here on the Kubernetes UI. We've got our patient detail domain just being deployed into our system. So that is now running. So now we have our storage defined. We've got our Jane's form to fill out, but we don't have anything that connects the two. So to do that, we're going to use functions as a service. So we're going to use kubeless here to do that. We've got this, let me make this a little bit bigger for you guys. Cool. So this is our kubeless function. Basically, it takes in an event, and then it strips out the information that it needs to make to populate our storage model, things like full name, gender, birthday, ethnicity, and then it's going to do a post to whatever domain we want when this is invoked. So I'm going to change this here to point to the domain we just deployed, patient detail. Cool, and then I can hit save. We can open up this log thing, UI here. We can see that we've just got a new patient form function being deployed. Now this has filled that gap in functionality. So that new one starting up now. Cool, so now from Jane's home, Jane can fill in this form and all that data can be stored and readily available before her appointment. So we've got ethnicity, her birthday, and her gender. So when we hit submit, we have success and her details has been submitted to the doctor. So now what we've done here, we've got a subject matter expert defined domain model using our DSL tooling. We've filled the functionality gap that we had using functions as a service, and now we have those patient details captured. So Melissa, the GP, has all the information that she needs before the appointment to calculate Jane's risk. So if we go back to this context diagram here, we can see that we now have the create function and define domain bubbles filled in, and we've got one left to go, which is deploying the machine learn model. So then we take you guys to the machine learning as a service demo. So this is our NZ risk model. Sorry, I can't quite read that there, but it's basically, so this is a model that we developed in Orion with partnership with Doug Campbell, who's an anaesthetist at WDHB, and it's a model that's trained on New Zealand data to calculate perioperative mortality risks for New Zealand patients going into surgery. So that will give you a % risk on your chances of surviving in the next 30 days following your surgery based on some attributes. Ooh, what have I done? Cool, there is a deploy button, but I can't see it. It's down there. Oh no. How do I get out of full screen? Huh? F11, got it. Sorry guys, I needed to deploy this, but I can't find the deploy button. And sorry, oh, it's a disaster. Smaller, that's right, I made it bigger, I remember. Cool, well, there it is. That would be on the doctor's screen. So basically there could be like a whole catalogue of all these different models, and the doctor can just select which ones they need for whatever consultation they have, and then they can press deploy. Great, so now that model's deployed, I'll show you guys that in Kubernetes. So you can see here, now we've got the NZ risk calculator deployed into our system. So now we've got our model. Now Melissa can add in all of Jane's information on her surgery before the appointment. So this is an elective surgery because she's going for hip surgery, and an ASA of 2, surgical severity of 3, and Jane has not had cancer. So these are all the attributes you need to fill out the NZ risk function. You can submit that, and we get a score of 0.04%, which is very low risk surgery. So now Jane can be supplied this information when she comes into her appointment with the GP. So now we've filled in all the gaps of functionality to deliver Melissa the functionality that she requires for the appointment. So when they go to the appointment, now they can make that decision together based on that information that Jane got earlier, and they make the decision to go ahead with the surgery. So it's important to note now Jane can provide informed consent based on what information we gave her in the appointment to have that confidence to go ahead with her surgery. So that's the demo of how a patient would go through that journey and how they would interact with our systems. We also have a working development environment. Is it F11 again to go full screen? Oh, there you go, now you can see the link, which is our public calculators website. So this is a public website that anyone can go access, and it has all of our health tools that we've deployed. So we've got some machine learning models in there, as well as some other algorithms that you can go and interact with. And this was made in partnership with Precision Driven Health and Orion Health. Also, we're hiring. So if you're interested in joining our great team, we're hiring a UI and senior developer. So you're welcome to visit our LinkedIn. And thank you to our team that has made this demo possible. Yeah, that's it.